Okay, so to focus on operator overloading, what we are going to do first is to put all our cell phones in our how many cell phones do you have? Okay. 5 cell phones. Okay, cell phones away, please. Today we're going to kind of do a very quick review on operator overloading and go right to the end with all the things we are supposed to do. So I'm going to start, and these are the things that we learned. So I'm going to, I created a class that is very simple so we don't get involved with dynamic memory allocation and stuff. I created a class called bottle. So the bottle of mine is simply a class that it has a capacity and it has an amount in it. So like this capacity of this one is, I don't know, 500 cc's, and now it has 250 cc in it. So capacity, maximum capacity becomes the capacity that we have. So the capacity is which means amount cannot exceed the capacity. We good? That's my bottle. That's the implementation of my bottle. And when I'm creating a bottle, I can mention what the capacity is, but the standard bottle is 250 cc's. So I'm going to put 250. It's an unsigned integer capacity at 250 cc's. Okay? Now I want to overload operators to make this bottle be able to work with operators and work in a way they're supposed to. So just to quickly show you how it works, this is my bottle, and this is my main. Where's my main? That's my main. So essentially I'm saying I'm creating a bottle. When I create a bottle, because I didn't mention what it is, it's going to be 250 cc's, and the only thing it can do for now is to display itself. So I'm going to run it quickly so you can see how it works. Compile it step by step. And bring this one over here. Okay, so the bottle is, I come to the execution. When the bottle is getting created, the constructor will be called. Therefore, it goes to the constructor. I'm not mentioning what, because my constructor has, a default value of 250, that value will be passed to it. So when we look at the capacity over here, you will see the capacity is 0, but as soon as I get into it, you'll see the capacity is set to 250. And it sets the capacity, and by default, a bottle is empty. Therefore, I have 0 over there. Okay? I have 0 over here, and my bottle is empty, and I get out. Now it shows that this is today's session, and then it says display. So it goes to display. I'm not passing anything to display, so by default it becomes C out. It inserts bottle. It inserts bottle with open parentheses, then the current amount slash whatever amount it is, which is 0 over 250, and that's going to show that I have a bottle that has 0 amount out of 250 cc's in it, okay? And then when it returns the OSTR, that is a reference of C out. Therefore, it comes back in here. Because display returned the reference of C out, display becomes C out. It becomes a new name for C out. Therefore, I can end L into it and go to new line. And I am going to new line, and the display is shown, and the bottle is empty. So that's what I have. Now, what I'm going to do is essentially this. I'm going to start quickly go through the things that we went and explain exactly how we overload and we implement the overloads. Like that, we're going to kind of review all the good stuff that we needed to know, and at the same time teach the new stuff that we need to know about operators. So we said operators are literally functions. They're literally functions, but they can be called in two different ways, either like a function or like the operator that they are, okay? So the very first thing I want to do, I want to be able to add stuff to a bottle. To add stuff to a bottle, a good candidate for it is plus equal operator, right? To add something to a bottle. So that's what I need to do. I'll go to plus equal, and what I'm going to do over here, so this is with side effect, binary operator with side effect. This is where we are, and I want to implement it. So binary operator with side effect essentially has the following thing. Remember, A is type A, B is type B, C is type, sorry, A is A type, B is B type, C is C type. Essentially, C is of type of class C type, B is of class B type, because I want to put a general formula for it over here so you know. So essentially, when an operator, now I want to implement this operator. This operator belongs to B, therefore, and it returns an A as you see. So it should return A type. It belongs to B, B type. Operator, whatever it is. And then at right side, it receives a C type of type A. So that is the general syntax of an operator overload of line 27 with side effect. We are okay with this? With side effect. Are we okay with this? Okay. Now, I want you put one emphasis over here, and I'm going to mention it at the top over here. I'm going to write over here all A type, B type, C types in the following. Text could be const, whatever I'm going to call it, X type, cont X type, or it could be any of these. X type, const X type, reference, or X type reference. Based on what the operator, based by what the operator should modify or return. Okay? So if you are returning something by value, line 7 is what we return. An A type will return. If you are returning or if you are receiving something by value, it's X type. If you are receiving something by reference, depending on what the operator is supposed to do. So when I write over here, A type, B type, operator, yada, 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 this could be A type reference, operator, constant C type reference A, depending on what we want to do. This is the general format for it, but being constant or reference depends. If I want to change A, then I have to pass a reference. If A is a big fella, something's a big class, I want to pass through, I want to pass it by reference, but I don't want to change it, then it's going to be a constant C-type reference, depending on what I want to do. General format is this. Depending on what we want to do, we change it, okay? So this is the one with side effects. So I'm going to literally write that over here. So I want to add an unsigned integer to this. So what do? I'm going to write, and as you see, I don't have a destructor. Why don't I have a destructor over here?
They're not allocated memory.
That essentially we call that not having allocated memory. We say this class doesn't have any resources. Okay. So now in here I'm going to say it is returning. What is supposed to a bottle return? Bottle itself. So I'm going to write over here bottle. Is it supposed to be constant? No, it should be modifiable. Reference, operator, and then at right side it should receive whatever is that, right? What is it going, what I'm adding to it? Value of whatever it's getting. And that's an unsigned integer, right? So I'm going to pass an unsigned integer to it. Value or amount. So this adds value to my account. It has, operator plus equal. This is supposed to add value to my bottle. Okay? So I can implement it, and that's the operator plus equal that I have, and it returns a bottle. So I can literally right-click over here and go create definition on yada, yada, yada in bottle.cpp. So it creates it over here. As you see, this is exactly what it is. You see, A type, now reference, B type, and C type. Exactly the same. Depending on what it's going to be, you're going to design it that way. So what is the next thing I want to do? I want to add the amount to it. So how do I add the amount? I add the amount. How much should I add? What I would do over here is this. I'm going to say M current amount will be plus equal amount, right? But then I have to check. I cannot overfill, right? Yeah. Now, in here, I have to say, what do I have to say? I have to say, if M current amount is greater than M capacity, then I'm going to say M current amount is capacity. Essentially, the rest of it have overflown. Right? So if it became more, I'll throw the rest away and my bottle is full. At the end, what do I return? I return the bottle itself so it can be used for other stuff if needed. So I'm going to say return this. Binary operator with side effect. Are we okay with this? Binary operator with side effect. Problem down to here? Sorry. Talking too much today. And the implementation for it, the test for it would be to adding something in here. So I can say over here, B plus equal 120. Now I'm going to say B.display. And this is supposed to show me 120 out of 250. And I'm going to do it like this. As you see, it's 120. Then I check what we call edge cases. Edge cases, it means check to see if that if statement works or not. I have 120 in it. I had 120 in it. I'm going to go B plus equal. I'm going to add another 200 to it. Definitely, that's 320, more than 250, correct? Yeah. So now if I go B.display, this one will show me 200 out of 200. 250 out of 200, right? So as this shows exactly what operator overload mean. When you do a plus equal with an integer, the value always adds up. But for a bottle, it has a different meaning. Hence, overloaded. We good? Yeah. Questions? Suggestions? You look like a question mark.
I didn't want to ask because...
Why? It's like...
I was trying to figure it out myself first. So I was thinking, what if, like, instead of a reference for bottle over there, when we are overloading the operator, instead of returning the reference of bottle,
we return a bottle.
Returning maybe pointer or returning like pointer. I was thinking how that's gonna work.
Okay.
It's gonna work.
So I have two answers for you. Number one, you have to look at your use case, if you require something like that or not. So if the use case that I'm writing and I'm designing requires that the address of a bottle is returned for whatever it is in, then I'll return an address. If I am supposed to return an integer, like for example, I remember in one of my assignments, I should lose weight. In one of my assignments, I actually had a container, and I would say you can pour one container to another, and I said return an integer, and the value you return would be the overflow. You follow? So when you do plus equal, if the value was greater than the other one, it would have returned how much was spilling on the ground. That was my use case. Here, I don't have that. So depending on what your use case is, you design it that way. We good? Number two, how to be a student and learn in class. If you understand the concept now, don't wonder, what if I could do something else? That's not going to help you learn. Sorry, I'm not criticizing you, I'm just giving you hints. Yeah. If you capture now, that's why you should close this freaking dumb things and have a pen of paper, write that question, and see if at the end of class I did not cover that, then you're going to ask the question. These are, don't close it, I didn't mention, these are nothing but distractions. They mean beep. It means don't use them. Pen and paper, that's the best. Cell phones away, please. Okay. All right, so we good down to this point? Yeah. Okay. Next one. So what if I have another bottle? So I'm going to write over here. Oh, I need to be able, so this is plus equal, this added to it. What if I want to set some, I'm going to say this bottle has 20 cc's in it. This bottle has 20 cc. I want that. Okay? I don't want to add to it. I want to set it to something. Leave it open now. Don't worry. Leave it open. You can leave it.
I'm done.
No, I didn't. I mentioned at the beginning of the class, if you know how to manage these things, fine. If you don't, then yeah. I told you that we have only one processor, not two. Anyways, so if I wanted to set this thing to a value, how did I do it? How would I do it? It's easy. I simply have to say, so instead of that, I'm going to write bottle, reference, operator, assignment, unsigned, int, amount.
Unsigned and bottle.
What did I do? Unsigned.
The variable name. Yeah, the reference.
That's a new version of bottle. Seriously, I'm going to bring my own thing because I can't do it small keyboard. I'm really bad. I'm sorry. But anyways, I'm not mentioning it really. I have a broken wrist, and for that I have to use ergonomic stuff. With this, I literally feel this thing going click, click. It's a very weird feeling over there. So yeah, it's as if two bones are touching each other. So anyways, my apologies on that. Anyway, so yeah, so if I want to create this, it's essentially like the other one, okay? Copy. So it's literally like the other one, but instead of that, it's this, right? I'm setting the current amount to whatever they are passing in. If the amount is big, I do that. Yes?
You need to use a point.
Pardon me?
You need to use a point
For what?
to set it so that it won't change the value. So you can't change it.
Change what? Change the amount?
Yeah, like this.
Because amount is a small thing, I passed it by value. Because it's passed by value, if I change the amount, I don't care. But we're going to get to that soon, in 2 seconds. Let's say I want to make one bottle to be identical to another bottle, the point that you made. So to test this, now I can come over here and actually say B is set to 100. Okay, now if I do something like this, the execution will change to following. You see that? Now first it has 100 out of 200, 250. Then I added over there 120, it becomes 220. Then I put another 200. It didn't go further than that. We're good? Are we okay down to this point? Now, what if I want to set one to a bottle? I have a bottle over here, C. C, that has a capacity of 500, and it has 300 cc's in it. So in here I'm going to say C.display. Okay. Now I want to be able to say C is set to B. Okay? I want to do this. As you see, it gives me no error, no problem with it. Okay? It gives me absolutely no problem. But essentially, I'm pouring one bottle to another, right? I wanted to choose B and C. My apologies. So I have C over there with 300 in it. This one has 250. It's going to exceed the capacity and it's going to overflow. Okay, good. So I'm going to say C is equal. I want to pour one bottle to another. Okay, this is what I want to do. So the assignment over here between the two, how does it work? If I go in here and write C.display, actually I could have done something else to make it more, let me quickly do something so it becomes more visible, becomes more, easier to follow. So in bottle, I'm going to put over here something like character content, content, okay, and let's put over here, I don't know, 80, and I'm going to set it to, what do I set it for? Come on, you can do it. By default, I'm going to set it to, let's not put any defaults over here. So in here, now I'm going to add a bottle over here. I'm going to say const character pointer content. So I'm adding content to it. So I'm going to bring this one. The reason I'm doing this, I want to be able to see what I'm doing over there. You know what I mean? Copy. Where is the constructor? So I'll put it over here, Control V. And in here, I need to include cstr.h. Now in here, I can say str copy into content up to 80 characters, right? And in display, instead of that one, I can have, should I put the whole name, just the name? Yeah, I'm gonna leave the bottle there, but before the bottle, I'm gonna show the content. So I'm gonna say over here, content. And show that one. So it's going to say C bottle, something like that. So we know which bottle we are dealing with when I'm actually writing the code. And obviously in here I have to check if content is null. If content is not null, and content is not empty, do the string copy, right? Otherwise, if they don't provide the name, what do I write? Tell me.
Default?
Huh?
Default?
Default bottle?
The word default or empty or I don't know.
No, and not empty. What? No, it is exist. That does exist.
No name.
No name, no name, no name, no name, no name bottle. Thank you. That's a good one. Okay. No name bottle. So that's no name. I wanted to have something. You know what I mean? So that's that. Now I can even make this one be null PTR. So if they don't mention it, it becomes no name, right? So I'm gonna save it and come back in a program over here. In here it's saying 500. It can't. It has to have a name. Oh, so now that I have done this, I'm a bad boy. See, it's always like this. When something, where is it giving me that?
Oh, that's just ID being slow.
No, it's because the null pointer is only in the definition and not in the constructor thing.
It is not supposed to be there. It is only, I think it's a bug. My, you see, actually reversed it.
Yes.
Yeah. I requested them to update my Visual Studio. Visual Studio has some problems. I don't think there's a problem in here. I don't know why it's, let me compile it. Compile. Where's compile? There you go. There you go. It is good. I don't know what the heck is that. Okay. What I wanted to do was this. Forget it. I'm making it too complicated. Forget it. The purpose that's, again, you are just witnessing being obsessed with programming and making things.
That's the mind of
Don't be a hero.
That's the mind
Remember
of
I told you when, like, I want to demonstrate for you what is operator overloading, not to create a perfect model over here, okay? So don't fall into this rabbit hole. It happens, okay? So anyways, I'm just going to come back over here, and in here I'm going to say, I'm going to call it C. So that's bottle C that I have, and the other one is going to be bottle B. And I specifically put equal to B to remind you that assignment at the moment of creation is not an assignment operator. It's one argument constructor. Okay, so you're essentially saying set that one to the name B. So it still calls that one. And now if I run this, I can actually see what the program is actually doing. Let me quickly go through it, and then we continue. So now, as you see, I have a C bottle over here. I have a C bottle that has 300 out of 50, right? Then the B bottle is 100. They come down over here. As you see, the last display over here is this B bottle, right? Now I poured everything from B to C, and I did not even overload the assignment operator for it. Why? Because objects of the same type, if you do not overload the assignment operator, a member-wise copy is going to happen. It means compiler blindly does a Xerox copy from one to another because they are both models. But I don't want that. So I have to overload to make sure this assignment is pouring one from to another and not just assigning everything, making a Xerox copy. That's why I'm going to come in bottle over here and actually overload that one. And this is where the constant thing comes to play. Now I have to say, so essentially this is what I'm going to do. I'm going to say I have a constant bottle reference other. Another bottle. That's constant. Why? Because bottle is a big thing. I pass it by reference, not value, and I don't want it to change. Does that make sense? Okay. Now I can actually It's supposed to actually give me a thing, but it doesn't. But so I'm going to create a Control C. I'm going to come back over here and implement that one right over here. So and it belongs to bottle. Okay, so essentially I want to pour the value of one bottle to another, right? That's what I want to do. I'm not going to write code for it. It's a waste of time. I'm just going to say return operator equal, and then in here what I'm going to write other dot m amount, current amount. I'm reusing my code. The code above is doing it for me, right?
Yeah.
I'm simply saying take the amount inside the other one and using that operator, because operators are functions, right?
Yeah.
I could do that. Are we okay with this? Not too complicated, right? All right. You will see, you see that in many places they do this. Instead of writing that return statement, they write this. Return this equals to other dot m current amount. This will work too, because this is the current object. Equal is operated overload, so this will be called. Why? When you have the function, put the bloody function over there so people can see what you're calling. Don't try to hide stuff. When you know that the function is called like that, I write it like this. It's more obvious. It's telling me that that function is, I don't need to rely on my knowledge. It just reminds me that. So I don't like line number 28. I'd rather do line number 29. They are both the same, identical. But you will see them both happening. Okay, are we good? So now if I run this program, you will see that 3 years later, oh, I forgot to, the last one is now a C bottle and has 250. Oh, I assigned it. Yeah, I assigned it, which means the other one's empty. I could have done a plus equal. So add a plus equal too. So you can do a plus equal between bottles. So you add one amount to another. I assigned it, which means I throw the other one out and then I put this one. So that's assignment. If you could simply overload the plus equal for it too, so you can pour from one bottle to another. Too many examples of the same thing. You do these yourself. Okay? Yes?
Before defining the last overload for equal sign, we did use that we used the method, right?
No, you didn't use any method.
I mean, we
You used the default action of the compiler, which is essentially copying everything from B into C. Everything.
Oh, so that was the default behavior without the overload.
Assignment between two same classes work.
Because what does it do exactly?
It does a double copy.
It does a copy of the.
You have no
object
access.
into
It does. So it literally goes byte by byte, copies everything from one to another.
Yeah.
Okay? Okay, so now we are good now with binary operators with side effect. Are we okay? So now, where is it? Now I'm gonna go over here, right click, go over here and go. So this is what I'm going to do. I'm going to go commit. Binary operators with side effect. Commit and push. So if you want to know which one is what, you go to the log and it tells you exactly which one is what. Okay? This is how you use your GitHub. Okay? Okay? And yeah. Let's not, okay. So the next thing, yes.
I have a question. So basically, in the third function, we in plain English, we're referring to the bottle.
You have a very calm voice, my friend. Use your opera voice. La la la, so I can hear. Okay.
So we're referring the bottle again, and then we're returning the object. Why
Give me line number so I know.
29.
29.
Can't we just return order.m current amount? Like, why do we have to refer to the object again?
You're talking about this one?
Yes.
Because I want to implement the same business logic. I want it, if it overflows, to take care of it. Otherwise, I had to copy the whole thing in here. Pouring from one bottle to another remains the same. You have to follow the business logic, which means you cannot pour more than capacity. So I am like this. When you reuse your code, if business logic changes, you change at one place and it applies everywhere. It's quicker. Does that make sense? All right. So now I want to do binary operators with no side effect. Essentially means I have bottle D and I want to do D is equal to B plus C. And then I want to say D.display. Does that make sense? So I want this plus to happen. First of all, so we're going to come over here and see what is the format for it. So this, what I have written over here, where's the syntax? Here. Syntax was like this, right? Binary with no side effect, syntax is the following. Got it? It's exactly like this one, but this one says I can't change the owner. That's the only difference. Got it? So now I want to implement that. I'll come over here because I'm lazy and I have two bottles. I'm just going to get these to copy this. And here I'm going to go const. Now let's analyze the return value. I am returning a reference. Wait a minute. When B plus C is happening, any of these two bottles are supposed to be returned? No, it has to be a new bottle. It cannot be just any bottle. It has to be a new bottle passing by. Because it's, if I return B, it means I have to change B. If I return C, it means I have to change C. But this is not supposed to change either. So to create the sum, I need another bottle.
Is this no side effect?
Yes, that's no side effect. With no side effect, I cannot return a reference. I have to return a new one. So that becomes my bottle. So now let's come over here and set that one. Obviously, this is a member of bottle. And it's operator plus. I did an assignment over there for some unknown reason. Where is it? Where's the plus? Okay. So it's a plus operator between the two. Okay, this is going a little cuckoo, which is fine. Okay, so now I have this. So I need to have a bottle, right? So the very first thing I'll do over here, I'm going to create a bottle. I'm going to say over here,
Sample, auto sample.
S for sum, okay? And I'm going to put over here S. I don't care about the title for it because that title is going to go away anyway, right? So I'm going to say this is S. And the value that it can have could be the it has to have a capacity. So the capacity is going to be the capacity. I'm going to put the capacity of both because there are two things being added. I don't know what is the bottle that is coming out, so it has to have, it has to be able to get the capacity of both. So I'm going to say my capacity, M capacity, or to put emphasis for it, I'm going to say this capacity, M capacity. So it means the capacity of mine plus the other dot M capacity. Oh, it's a plus between the two. Why did I put a comma? Okay, so I'm saying create a bottle for some, call it S, put it there, put the capacity of me and some of the other, make a bigger bottle, right? Now what do? All I need to do is to set the value of that to the sum of both. So I'm going to say return S equals to this M current amount plus other dot current amount. Because this operator over there returns the reference of the 1, so the reference of S is returned. Now, my operation has a meaning. So B plus C actually happens. And if D has the capacity for it, which is not, so let's put 600. I'm going to put, I'm going to make D over here, say, with 600 cc capacity, okay? Now if I run the program, I have 500 out of 600 in bottle D. Are we okay? Because C had 250, B had 450, and that's 500 of C. Okay? Are we okay down to this point? These are all the things that we learned already. Now, if I want to add 1 cc to it, what do? I need to do a binary operator, do a plus plus for it, right? So essentially, I want to be able to say, hey, I want to add 1 cc to it. I want to do that. And then go d.display. So a unary operator, because it doesn't have an argument, it belongs to the object. Therefore, in here, all I need to do is to write bottle. Obviously, it's going to be reference because it's going to return the D when it's done. Then I'm going to say operator plus plus, and that's that. And now create the definition for it, and all I need to do is to do over here M amount. Actually, I'm going to say return operator plus equal 1. Why? Because if that 1 goes more than amount, it has to fix it, right? So I'm reusing code. So I'm saying add 1 to it. Are we okay with this? We good? Okay, so now if I run the program, we will see that it's going to add 1 to it, and it's going to be 501. 501. That be good? Next, I'm going to empty bottle C. I can do that, right? I'm going to empty bottle C. Then I'm going to get C is equal to D plus plus. I want to implement that. So plus plus comes after. Okay? Then I want to see what are the values of C and D. So in here I'm going to say C.display and D.display. Oh, C is not big enough to hold the value. Okay, I'm gonna empty D. D, I'm gonna set it C. I'm I'm going to set D to 0 because it has lots of volume. I can put stuff in it. Now in here, I'm going to say D is set to C++. Cool. Okay? So whatever the value C has, it's going to, I wanted to add 1 to it, then I'm going to show C and show D. So in here, I'm going to have D. So I'm going to show D.display and C.display. If it was an integer, D would have had the value of C before being added by 1, right? I'm going to show you that that's not the case. First of all, this operator overload is weird. It is a unary operator, but how can I create a new signature for the damn thing? It is exactly like this. There you go. This should be the on. Because they're both one operator with one owner, right? They freaked out. They said, the heck with it. Let's do something weird to make it different. They said, just put an int over here. That int means nothing. That only means it's postfix. So int in here doesn't mean it has a variable or argument being in. So int means postfix. So in here I'm going to say no int prefix. Int means postfix. Got it? Now I'm going to actually do the same thing, and I'm going to go over here, do that. So essentially I'm going to write the same code, Control C, and put it over here, right? So it's doing the exact same thing. Now, to show you that operator overload really means overload, this is my case. Take a look. They're both 251. If it was plus plus that happens after, if it's plus plus that happens after, D were supposed to remain 250, correct? And C would have been 251. But because it's an overload, it doesn't mean anything. You have to reinvent the wheel from scratch. If you want that to happen, we have to play a trick. You know what's the trick? Take a look at this. I'm going to say, you want the old value? I'm going to play a trick on you. I'm going to say, I'm not going to send the current object because current object is added by 1, right? So I'm just going to remove that and remove this. Okay? Then I'm going to fool you. I'm going to say, hey, I'm going to create, what do I create? I'm going to create a bottle, copy, and I'm going to set it to this. So copy becomes a copy of the current one, right? So the copy that I have is the copy of the current one. Or let's call that old. Old. And then I'm going to do this separately, and I'm not going to send it anywhere. And I'm going to return the old value out. So what I'm doing, you want to add 1? First, I'm going to copy what it was before. I'm going to add 1, then I'm going to send the old one. So I'm going to send the 250 out. So it looks like plus plus that comes after now. But it's not really. I just programmed it that way. Are we okay with this? Are we okay with this? Are we okay? 1, 2, good. Now, what if I want to know what is the amount of something? So I want to write something like this.
So we're finished with this?
Yeah.
Because it's post increment, right? It has to.
No, it's not post increment. I made it look like it. It's an absolute lie. It's just a function. There is no post increment. It is. It is the post-increment operator overload, but I could make it decrease the value if I wanted to. Because I'm creating a new function, I can do anything I want to do with it. But if I want to make it look like it is happening after the fact, like, yeah, so then I have to jump through hoops to do it. So I have to fake it. So in here, I'm going to say, literally, I'm going to say, faking post increment. Does that make sense?
Yeah.
Okay,
So
good.
it actually is not happening.
It's not happening. I'm faking it.
You justify time anything.
Yeah, because it's a new one. Now, what if I have over here integer amount? Okay, and I have integer amount, and I want to set that amount to the amount. I want to set that amount to the amount of D. Is integer a class? No. Can I add them up? No. So what do I need to do? What really compiler does when you have an integer at left and a double at right? Does it work? Yes. How it works? What does it do? Okay, if I had integer a at left and I say a is equal to 3.14, what goes to a? So what happened to that 1.4? Typecast. And I can overload typecast. I can actually tell to the compiler, if you see an integer at left, you can cast the bottle like this. How do I do that? I can say, so in here I'm going to say typecast overload. Okay, it's an operator, right? And I'm going to change the meaning of int, correct? Do I change what I have? No. So that's const, right? What is the return type? I don't need a return type. I'm just telling that it's going to be an int. So there is no return type needed. I am saying convert me to an integer, which means the return type is an integer. It is within the definition of the typecast overload. Therefore, now in here I can say bottle operator int. Because it says operator int, I know it's a cast to int. Okay? What do? I return the integer version of m. What is that? Current amount. Why? Because that's an unsigned integer. It has to be casted, right? So now, if I look at here, I have no errors. And I can say cout amount amount, and I run the program, and the amount is shown. Ta-da! When you go home, press F10 and F11, walk through this, and see how it works. But wait a minute. I want to be able to do this. Amount plus equal C. I want to see what is the sum of dn, and I want to return it. I want to add. Now, first of all, why it's not giving me an error? Can anybody tell me? Yeah, because when you do like this, compiler says Can I cast it to something so it makes sense? Yes, it's going to cast it to an integer, right? But if you don't like it, you can overload it. How do you overload when the left side is not a class? It is what we call a non-member or a helper operator overload. A helper operator overload is not a member of your class. It's a standalone function. And the syntax for it is I'm going to copy it. And I'm going to say helper binary operator with no side effect. By now you know. Pass a reference, it's a side effect. Pass a constant reference, it's no side effect. So no side effect, BS. Design it any way you want. It's the function you are writing. Although it's an operator overload, it's a function you're writing. All it needs to do is to have the exact same signature of the operator. What you do in it is your choice. You can do anything. Okay? So now, the helper operator that I have over here, no side effect. So essentially, it's going to be like this. It returns an A type. Okay? It doesn't belong to anybody. It's just an operator. At left side, it receives a B type, left, and a C type, right. Done. So this standalone helper means at left side, I have this. At right side, I have that. Now, in here, at left side, what do I have? An integer. At right side, what do I have? A constant bottle, because I don't want to change it, right? But left side, I want to change, so it must be a reference. Correct? So what do I need to do? In here, I'm going to say over here, okay? In here, I have to say, not here, here, because it's a non-member. Helper operator overload. At left side, I have an integer, so in here is, oh, I am returning an integer, right? And the integer I'm returning, it's supposed to be amount, correct? No, actually, it's a copy of the amount. It's not the amount. In reality, it returns a copy of the amount.
Isn't it plus equal? Shouldn't it return the amount itself?
Yeah, sure, amount itself. Good, no problem, amount itself. So in here, it's going to be an integer reference operator. Right side is an integer reference left. At right side is a constant bottle reference. What is that? Bottle reference right. Okay, so I write this code. Now, oh, operator plus equal. So now, let's design this. Again, it goes into the same place, but it doesn't belong to the thing. Remember that, okay? Now, what do I want to do? I have the left, right? I'm going to say left. Okay, let's first ask a question. We have till 5:05. I'm not going to give you a break. I'm going to finish this and we go early. Is that okay? Yeah. Okay. I want to ask you a life question. What are friends for?
Support.
Support. What else? Don't me answer.
Socializing.
Socializing. Okay, what else? Seriously? That dead? No personal life, anything? You just like all nerds? No friends? What are friends for? Anyone? Seriously, you don't want to fall in a trap? Okay. In object orientation, you know what friends are for? Knife in a back. That's what friends are for. You know what an object orientation is? Is that close, dear friends of yours that you go for a trip You give the key to water the plants. You come back, you see your mother's necklace is gone. Who becomes a friend? Your close old friend becomes a thief, right? Immediately. Friends in object orientation are knife in a back. Therefore, the example I give you, you will never use. It's a bad thing. Friends are used for something else. Friends are to implement ownership. Friends is like you have a dog. Dog is your friend, right? No, you can take it to the vet, put it down tomorrow. It's not your friend. You call it a friend. Okay? So you become the friend of your dog. That's what is in C++. In C++, friends are for ownership. You never hand in the key to your class to anyone. So why I mention that? Because in here, if I say left plus equal right dot m amount, no, what is current amount? It's going to tell me what? Member yada 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 declared it's inaccessible. Hey, you are accessing private stuff. So what do? I'll copy, and then after doing this, I'm going to say return left, right? Obviously. So what do? I take the definition over here, copy, and I paste it over here, and I write in front of it, friend. Now, you can access anything inside the thing with an outsider function and destroy the class if you want. You never do that. If any of you ever uses a friend for a function, 0 for your implementation. This example is only to show you, because you're going to see people do this. Writing a friend for a method is laziness. It means you didn't want to implement an accessor method, a query, which we had. All I needed to do is cast the right to an integer and I was done. I didn't need a friend, did I? If I casted right to an integer, problem was solved. I didn't need to have any access for it. This friendship is not supposed to happen. It means laziness. So I'm going to say very bad thing to do. Never do this. Only never do this. Okay. And in here I'm going to say, and I'm going to copy and paste this over here, and I'm going to write over here bad implementation. Bad implementation needs friendship. Okay, and I'm going to comment this one, and instead I'm going to just do this. Don't worry, it's a comment. It's not going to hurt anybody. Oh, what I'm going to say. Where? Oh. Thank you for your. So, see, I don't need to do that. It's done. Are we good? Are we? Huh? What error?
Right curl and
Too many, the closing curly brace, I think, is an extra one.
Where do I have an error?
Line 61.
Oh, why do I have an extra curly bracket over there? There we go. I don't know where it came from. Oh, it was, no. Yeah, anyways. So now it works. Now the amount thingy will work, and that's that. But look at my main. What is this display thing? I hate that. Okay, so in here I'm going to say a pre-O stream. I don't want to. So we've done all these, so we have the thing for it. We know what's going on. Now, what I want to do is to be able to say, I want to do this. First of all, why didn't I get an error? If I run it, it will work.
Has to turn it.
Yeah, it's going to. It's not going to work. It's going to show the content of. It's going to show 300, because C++ tries to solve the problem. Can I somehow make this thing printable with cout? Yes, cout can print integer, right?
Yeah.
So it's going to print. So if I run it like this, it's going to just cast it and show this. It's going to say here is 300, which I don't want. I want the bottle to get printed, right?
Yeah.
So instead of doing this, I'm going to look. What is this? What is that left side of C? Cout. What is the type of cout? O stream. So at left side I have O stream. At right side I have bottle. Can I go and change the source code of O stream? No, I cannot hack C++'s library. Here is again when you use friendship. Throw it away. Here, helper functions, okay? Here's where you should use help. So I'm going to say at left. So first of all, I have to return an O stream. Why do I need to return an O stream? Because I want that end L to be printed or anything that comes after. So it must leave O stream afterwards. So I'm gonna write over here O stream, reference, operator. What am I overloading? That one, right? And I'm gonna say at left side, I have an O stream reference, not constant, because you're printing on it, right? So this is gonna be left. And at right side, I have a constant bottle reference right. And here you will see that I have done something wrong. And I did it on purpose, but at this moment you will see that. Come on, you can do it. Okay? So first of all, this is O stream, it's wrong. I have to say std O stream because it's in a header file. std and std. Okay, because I cannot use using. So this is this, it's created. I'm going to go over here and say create definition. So it created the definition. And I need to include O stream here now. Include IO stream and using namespace std. Okay, so let's come down. Now I have this. So what do I need to do? I need to display it, right? That's why I always said your display should return an O stream and receive an O stream. Well, all you need to do is to say return right dot display, and you pass the left to it, which is going to give me an error. Why it's going to give me an error? Because say you said bottle is, you are calling display, but your display is not constant. I designed it incorrectly. You see, it worked for everything. It displayed, life was beautiful. But this is one of the things that students say, but it works. No. When you are writing a function that tells that it tells you that it's doing something that by nature is constant, you must make it constant even if it works for now. So this needs to be const. It's not going to make any difference for the previous one. And where's my display over here? And const over here. Because I'm not changing anything. And now my function works perfectly. It passes the O stream at left to this one. So this is going to print on cout. it's going to be bottles display, and it's going to return. So essentially, it passes through your display and goes through. Just to see these two things together, I'm going to bring this down. Okay, so now, let me run the program. This one I'm going to walk through, okay? So it comes in here, sets all these stuff, says, here is it was such a nice thing. You could do it like they have to put 50,000 things over here. Boy, you put it at left. Life was beautiful. Okay, now, so now we're okay. We come over here. Now we go to see out. I'm pressing F11. As you see, it says here is. So the first one is called. See out is now here. It comes in here, goes to display, passes see out. See out becomes O stream, prints it, and comes out, goes back in here, prints the new line, and it's done. Now your object can be displayed over the schmiggly-dingy, the O stream. And you can do the exact same thing for C in. All you need to do is to create a read function, do it at home, create a read function. Obviously, it's not constant because you're changing. And in your read function, put some kind of a comment. Enter, I don't know, bottle value or something. And then you read, and then you can actually do C in into C and read the value of the bottle. Okay? We're good down to this point? Now, I have two values in here, correct, in that bottle thingy. Three values, actually. No, two values. I have an int, unsigned int over here and unsigned int capacity, right? I want to be able to access both of them very nicely. What if I could do something like this? Saying, what if I could do something like this? See out capacity is, it's the first one, right? So I would think as if it's an array of two unsigned integers. So I'm going to say C0. And I say C out amount is C1. I wish I could do that. I can. I just overload the index operator. How do I do it? I'm going to say over here, subscription operator overload. Now in here, I'm going to say, it's going to return an unsigned int, right? Unsigned int operator index, operator index, and it receives, let's say, size t index, and it's not going to change me, const. I don't want it to be, oh, I can make it actually even change it if I want to, so they can set the capacity, but I don't want to. I want it to be constant only, let's say. I want it to be read only. Again, if you remove the constant and return the reference of those, they literally can change them using index, okay? But we are not doing it. So I'm going to do it like this. I'm going to say, now I'm going to overload this. And I'm going to say if index is 0, in here I'm going to say what do? I do, integer value. I can actually make it equal to, let's just do it like this. So I'm going to put 0, I'll put -1. Oh, it's unsigned int, I can't do that. I'm going to show you something that, now forget it. I'm going to go in unsigned int value, and I'm going to actually set it to -1. When you set an unsigned value, what happens to -1? It becomes the biggest value possible, humongous. Now I'm going to say if index is 1, then val is set to m capacity, right? Then in here I'm going to say else if index is equal to 1, I'm going to say value is set to m current amount. Now I'm going to follow the rules, and in here I'm going to say return val. So if they receive a crazy value, it means they put a wrong index in there. Now I'm going to save it. Now this index thingy, when I run the program, works like this. Here's the bottle. Now I'm going to press F11. As you see, it goes into index. Index becomes 0. Because it's 0, it shows the value becomes capacity. Capacity is returned, and it's because the capacity is 500, and it goes to amount. Now it's 1. It comes to 1. It becomes current amount, and it shows the amount. So my bottle can be an array of 2 unsigned integers too. You can do anything you want with operator overloading. Make your class do anything. So that string thingy we were doing together, now you can actually change it to so it looks like an array of characters using the index operator. So we're going to go through that and practice all this on all those things, on bar chart, on string, and all the good stuff, so we learn how it works. So let me just see if there's any other type of operator overload that I'm missing in here. And if not, then we are good to go. Where is it? I'm just bringing the addendum up. I want to see what do we have. Yes.
You don't take attendance.
Wow. Good idea. Thank you.
No, you say each time.
Yeah. I'm going to do a good idea, actually. I have to see if I can do it quickly or not. If we have time, I will do it. Yes. I actually went online and saw if I can actually see an NFC reader. Find an NFC reader. Yeah, so I could put it connected to here and ask you guys to come and tap your one card and go. Okay? But it was like $120. I'm like, I'm not going to pay that much for that. Just come over here, beam, and you go and one by one it would add you, but sadly, it was too expensive. If you had your one card, like the plastic card, I actually have that reader. I could have done it. But I don't think anybody carries the plastic. Anybody?
No, they don't give it.
They don't give it to you anymore?
They do the apps.
Oh yeah, it says that's the thing. When it's in the app, then you have to do the NFC thing. Anyway, so is NFC or is NCF? What is NFC? NFC, yeah. Yeah, so anyway, so let me just take a look at what we are supposed to cover over here today. Like one of the, we don't have a, when you create a class, okay, now the class that I created, I don't let it go bad. Okay, I don't let the class go bad. But I could say if instead in my code, when I was writing these values, when I would say something like this, okay, what I could do, I could put the class in what we call an invalid, safe, empty. they call it safe empty state, but I call it invalid safe empty state, which means you set either a flag or you make an impossible thing. Like, for example, as soon as it goes up, then you would check to see if the value of the current amount is more than capacity, you make it invalid. And what you do, you overload the Boolean cast, and you say return true if amount is greater than capacity. Sorry, return false if the amount is greater than capacity, and return true if it's not. I'm sorry, I have to answer this. Hello? من توی کلاس دارم درس میدم. بله ماما، من توی کلاس دارم درس میدم. همیشه باشه، همیشه بعد از ساعت 5 لطفاً به من زنگ. من توی کلاس دارم درس میدم الان جلوی دانشجو. بای. All right. I am so sorry about this. I have to answer these calls. I have no choice. I explained it at the beginning of the semester, right?
Yes.
So I apologize again. Okay, so yeah, so we could change the code to show you the safe empty state. But then it's defies because I didn't want to just do a plus equal. But anyways, you could do that. When it goes like, I can set the amount over here like that, and I can have this, let's say over here, let's do this. I'm gonna in here, I'm gonna call it over here Boolean overflow. Okay? By the way, you can set all your values, all your values in the class right there. If you do that, then they will automatically get those values no matter which constructor is called. Remember that. So I could simply write over here false, which means in all my constructors, overflow will have a value of false. I don't need to set it. Remember that. Especially for dynamic memory allocation, that comes really handy. Okay? So in here, I'm going to call it M overflow. And then in here, at any moment, if the overflow is happening, I will set that one, but I'm going to say M overflow is set to true. And in here, I'm going to say again, M overflow set to true. Do I have it anywhere else? No, that's it. So that sets the overflow. Now I'm going to come in here and I'm going to go to the typecast operator. I'm going to say operator, Boolean, const. And I'm going to set this operator Boolean const of mine to return not overflow. So now it can show me if overflow happened or not. So in here, I'm going to say, I can, instead of just returning O stream over here, I can actually write an if statement saying, if this is in good state, as you see, I'm just writing this, which means it will be casted to a Boolean, and it becomes false when it comes down. Now I can actually check the safe state of it. Either write something in display over here, or make the display show. Oh God. Something is happening. Yeah. Anyway, so yeah, so didn't I put this thing on? Yes, do not disturb. Anyway, so now that I put that one over here, now, where is it? Now I can come to the helper operator here. Instead of just returning, And in here I can say if not right. Now, it actually came out nice with the if it's not right, no. But if it's not correct, if not right, write an additional thing saying left spilled, and then return. So now, when I'm printing it on cout, if an overflow happened, it's going to say it's a spilled bottle with this value. It means you had an overflow, something like this. This is called a safe empty state, and you can even stop working with it, so you can actually see if something went wrong. And when you have something like this, after you dealt with it, you can clear the state for it, and this is a very usual thing to do, to add something, bottle, clear, and the clear, what it does, it sets the overflow back to false. So in your logic, you can say, if the bottle is not in a right state, you take action, because I had an overflow, and then when everything is done, now you will say clear, which means now bottle is in a clear thing, I washed the outside thingy, and everything, now I can work with it. So you can actually clear it, go back to it. This is called safe empty state. Planning for a detectable safe empty state. Okay? This is extremely important to have in the class. So quickly look at this. Course information, addendum. All right. So we are on week 5, right? Oh, week 6. Helper operators and operators, input and output. We'll talk about that in, so essentially it's, please study it yourself, the input-output operators. It just shows you all the methods for C in and C out. How to do left justification, right justification. The next day we're coming in, 15 minutes at the beginning of the lab. I'm going to explain it to you because you look exhausted. I can keep going for 15 minutes and finish the whole thing. You want me to do that? No, so, okay, so go, the voice like having a, okay, so please go study it. It's very simple. It's just showing you the methods of C in and C out. Set the width to something so it prints it this width, left justified, right justified, how to do formatting in C++. And in 10 minutes, I'm going to go through everything. So when you're coming, you're going to do that, and you have a test, you have a quiz too, okay? Remember that. Not on operator on week 5, whatever we had in week 5. We had operators on week 5, right? So not helper op. So you're going to have this, member operators and current object. These are the things that you're going to have questions about, okay? Writing some operators.
You're gonna post the thing like last time?
Yeah, but essentially this is what I'm going to say. In your next quiz, you're going to implement member operators and use... Yes.
And then the following week is the test.
Yeah, and the following week is the midterm.
I know.
Are we okay? We good? All right, let me pack stuff and give me 2 seconds. Oh, let me just stop the recording. Give me a second.